Clean water, our lifeblood, and the lifeblood of our environment. 60% of our body is made up of water, and 80% of the world is submerged below the waters contained in the oceans, rivers, and streams that cover this planet called Earth. Over time, we've seen the negative effects on the environment caused by our careless consumption and pollution of this most valuable resource we have, clean water.
Back in the 1950s and 60s, when a lot of cleaning agents and pollutants were being discharged into the river, on certain days the turbulence below the Bangor Dam would create foam that would stand up hip high on the water. And many times while fishing, I've rowed my double-ender boat through that, and it would leave a corridor of standing foam where I rowed. And the river is cleaner now than it has been in the last 100 years. You can see it all along the Arlington shores down there. You see people using the river, boats, people swimming in the river, which you didn't see, 30 years ago, 30, 40 years ago. And that's all because of the improvement in water quality.
The tremendous improvements made in water quality over the last 20 years are the result of a 24-hour-a-day, 365-day-a-year effort of the main wastewater treatment facilities located throughout the state.
Wastewater treatment facilities play a critical role in protecting the waters of the state, both from an environmental and a public health point of view. The treatment that these facilities provide for discharges in communities and industries maintain a high level of water quality both for fishing, swimming, and other uses.
What is it like to work and operate a modern wastewater treatment facility?
Every day is different at my job. It's exciting. It's not really what people think. Most people might drive by a wastewater treatment plant and hold their nose. It's really not a whole lot of that in the treatment plant. A lot of it's biology, a lot of advanced electrical and instrumentation things that most people wouldn't know just by driving by, especially our plant. It looks like one large cement tower and some big buildings, but once you get down underground and into the bowels of how things work, it's quite interesting and quite diverse compared to what they might think. In a typical week, I guess I'd be exposed to several different things. I may be troubleshooting different electrical systems in the plant that may have gotten wet or may just be acting up due to lightning or for any other given reason. I could be actually working on motors or pumps that have failed for some reason or another.
Modern treatment plants are not only made up of pipes, motors, electrical controllers, and computers that collect, process, and monitor the condition of the water at all stages. Much of the work in today's modern plants is accomplished by minute organisms that can only be seen through a microscope.
The types of things they'd be seeing if they look through a microscope would be all the different types of microorganisms that wastewater treatment plants cultivate in order to remove pollutants from the wastewater before it goes into the river. The other types of things that they would be looking for are bacteria that sometimes causes problems, and and we would talk about the things that wastewater treatment plant operators have to do in order to take care of those kinds of situations. So it's not always the same thing every day, and that's what also makes it interesting. You go into work, you leave work one day, you come back the next day, and because we're working with a living thing, the situation is often very different the next day. So those are the types of things that I think would spark their interest, and those are the types of things that keep me interested in what I'm doing.
Daily testing and monitoring of the incoming wastewater biosolids and microorganisms is the balancing act of the lab at each individual facility.
Take, for instance, the other day we had low dissolved oxygen on our aeration tank, so it was a matter of actually putting another blower on to keep those oxygen levels up, because we need the bugs that are in here, we need to keep them alive. And this whole plant runs on keeping these little critters alive.
What we need to do is understand how we can use those bacteria that live in the sewage treatment plant to break those things down before we actually discharge them out into the environment where they can do some harm. So some of the most interesting work that's being done in the field right now is working out how these microscopic organisms break down the bad pollutants.
Wastewater treatment plants are highly regulated facilities with stringent guidelines governing the quality of the treated water. New technology has made it possible to test for and remove pollutants measuring in parts per billion.
In the last 35 years, the accuracy of the laboratory instruments has gone from thousands to 10,000s to millions to parts per billion. We're now measuring more accurately than ever before.
And so you get an idea of how much we have to clean the wastewater. A part per billion is if you took like a quarter of an aspirin tablet and you diluted it in a 16,000-gallon tank car, like a Ted car that you see on the railroad tracks. So we're talking about very minute amounts that were allowed to discharge into the river.
Each year, hundreds of students visit wastewater treatment plants throughout the state. These educational visits serve twofold. Students learn about the process of and the importance of treating wastewater. Additionally, they are exposed to the differing types of careers available in the field of water treatment.
Chemistry, water chemistry is an important area. Biology, understanding how things in the environment are going to affect organisms that live there. Physics, so that you can get a handle on different ways of cleaning up water. There's a lot of physical methods that we use. Ecologists are very important to figure out how water contaminants and pollution are going to affect organisms that live in the environment, fish, birds, aquatic insects. All of these different fields sort of join together into this little world of wastewater so that we can get a handle on what's going on and try and fix it.
There are opportunities within this industry for a broad range of capabilities, interests, and specialties. For example, someone that's interested in chemistry and the interaction of whether it's organic or inorganic chemistry, that fundamentally is the principles that we're working with to treat wastewater fall into the chemistry and the biological or biochemistry fields, and someone that has that interest could find a great opportunity in the laboratory aspects of a wastewater treatment plant in performing process control and compliance testing and monitoring. From a biology interest, the majority of wastewater treatment plants in work today rely on microbiology, bacteria, to accomplish the wastewater treatment. We use their innate ability to use organic matter to reproduce as a technique to treat our waste and clean it up. So management of a biological system is exactly what operators in our wastewater treatment facility do on a day-to-day basis. In essence, you're responsible for the care and feeding of a biological system to accomplish wastewater treatment. So we rely on machines that are driven by electricity to provide the air we need for treatment, to provide the pumping capabilities that we need. So from an electrical perspective, we have a very complex power supply and distribution system that needs to be managed and maintained within our industry. For someone that's interested in computers or control systems, the industry today is breaking into supervisory data acquisition and control systems, or SCADA systems, and I see that complexity increasing over time with far more instruments and controllers out in our facilities, all brought together into a centralized system. There's a specialty branch of engineering, environmental engineering, that specializes in the unique knowledge necessary to develop wastewater treatment plants, but there are lots of opportunities for someone who has an engineering bent, whether it be mechanical or environmental, electrical, architectural, or civil engineering, as a matter of fact. All those specialties come together to create the designs that are necessary for these facilities. The future operator is going to be challenged with lots of very interesting things very interesting things that they have to manage, but very interesting tools to work with also.
Clean water is not the only byproduct of today's modern secondary treatment plants. The biosolids removed in the treatment process are recycled and have created an entire industry.
Back when I was young and growing up, we had a lot of polluted rivers in the state of Maine. And those rivers have been cleaned up thanks to the waste treatment plant industry. And a treatment plant basically is cleaning the water coming through it, and it has a byproduct known as biosolids. And those biosolids can be composted using forestry material from the main forest, the sawdust and shavings, byproduct of many of our forest products industries. We make a beautiful humusy product here that's great for plants, and over 30 Maine towns and communities in the state are using compost that is produced from biosolids. And they can be used on parks, cemeteries, ball fields, around the town office, and many private landscapers are using this as well to get great results. And so I feel really great, having been working for this company, New England Organics, for over 19 years, and in the recycling industry for about 25 years, that this is just one of the best examples of recycling. It's done close to home, it's returning the nutrients full cycle back to the land, and it's a real win-win for everyone.
The challenges facing today's treatment plant operators and the operators of tomorrow's plants goes far beyond the walls of the treatment plant, for it is the responsibility of the plant operator to meet or exceed the constantly changing environmental regulations and standards. This requires ongoing training and constant communication with other operators, regulatory agencies, manufacturers, and industry leaders. One organization that leads the way in this endeavor is the Maine Wastewater Control Association. Each year, they sponsor conventions and training workshops. These forums provide continuing education opportunities for plant operators, technicians, and management staff. There are interactive training sessions covering the latest in technology and regulations. The association and individual plant operators also participate in many community outreach programs, utilized to educate the general public. One such program is the annual Clean Water Week poster contest.
And there's no question that environmental management, water management, all those occupations are going to be very much a part of the future.